All right, let's turn our attention from horizontal motion to vertical motion, and we're going to talk about free fall. Free fall is actually very simple. If you are comfortable with horizontal motion and the equations of horizontal motion, going to vertical is going to be very simple. So what I want to do now is go ahead and give you the definition of free fall. And here it is. It's the motion of an object when the acceleration is due to gravity only. What I'm talking about here is things that are dropped or something that is tossed in the air and then returns to the ground. Once it leaves the hand, the only thing accelerating it is gravity. That is the definition of free fall. So what I'm going to do first is show you the transition from the horizontal motion equations to the vertical motion equations. And here they are. If you notice that there is an equation on horizontal motion that doesn't exist in vertical, and that's this one right here, is the average velocity equation, because when a ball or an object is in free fall, it is always experiencing some change in the velocity. So it's always experiencing some acceleration, which means by definition it can't have constant velocity. And I'm hoping with the activity that we did a couple of days ago, you did prove that as a ball is dropped, the longer it's dropped, the more the velocity changes. So here are the transition equations. I have VF is equal to VI plus AT. Over here, it is VF is equal to VI plus GT. Here it's VF squared is equal to VI squared plus 2A delta X. And here it's VF squared is equal to VI squared plus 2G delta Y. All of our motion horizontally converts to vertically. So we move from the x-axis to the y-axis. And if you're noticing, the acceleration is going from A, which could be any number, to G, which is 9.8, and I'll show you that again in a moment, or whatever it is on whatever planet you're on. For the most part, we are here on Earth, so for the most part, it will be 9.8. A few of your homework questions have placed the object on the moon or on Mars, and then it'll give you the gravity of those locations. And last but not least, I have delta x is equal to VIT plus 1/2 AT squared, and here it's delta y is equal to VIT plus 1/2 GT squared. Again, I have changed my acceleration over here to gravity over there. And otherwise, the equations are basically the same. All right, let's take a look at this lovely diagram. So this is what I mean by free fall. In this case, this is an object that's being dropped from a certain height and falls to a lower height. And there's one thing that is consistent on an object that's being dropped, and that is the initial velocity here is 0. The ball starts from rest, and then as it falls, it becomes faster and faster and faster and faster under the acceleration of gravity, which is 9.81 meters per second squared. And I'm going to go ahead and put a negative because acceleration is a vector and it has a direction. And for us, pre-AP, we're going to define up as positive and down as negative. And gravity always pulls things down. I have never known gravity to propel something up. So it's always negative 9.8 or 9.81. Sometimes I use either number. So don't get too confused. It's not that bad. All right, let's do a sample problem here. Let's apply all these equations and apply gravity and take a look at what it could look like on a homework assignment. So here's the diagram. I have a person on a cliff. The person has an object, a ball or a rock or whatever the object is. The cliff is 100 meters high. That is the delta y. So the change in the height is 100 meters. The initial velocity right now is 0. He's just holding it in his hand. Gravity is negative 9.81, and I did mention that the height is 100 meters. What you need to do is definitely list all the information you know. Then you can pinpoint some of the stuff you don't know. Once you list the variables you know plus the one you don't know, of course, by then it's easy to choose an equation to solve for the answer. So this is a two-part question. Let's do the first one. The first one is, what is the final velocity when the ball reaches the ground? So the ball is going to travel down, and what is it right here, right before smack, right before it hits the ground? That's the final velocity. So there's all of my givens, and I'm looking for VF. So I'm going to choose an equation with VF, delta Y, VI, and G. And that would be VF squared is equal to VI squared plus 2G delta Y. And the rearranged version is VF is equal to the square root of VI squared plus 2G delta Y. And then we substitute in our numbers. When I do that, I get VF is equal to the square root of 0 squared plus 2 times, and I'm going to go ahead and put the direction of these variables into the question. So negative 9.8, and it falls down negative 100 meters. Once I do that, then I'll go ahead and get my answer. I don't have my calculator, so I'm going to leave that up to you all. But here's some clues. If you make this negative, if you make gravity negative, you have to make the displacement negative, because mathematically, if you don't, you will be trying to take the square root of a negative number, and you'll get an error on your calculator. That's clue number one, that you're missing a negative sign. So definitely keep an eye on the directions. So that would be how you would do number one. Question number two says, how long does it take for the ball to reach the ground? How long does it take? Well, I know my initial velocity, I know my height, I know G, and now I'm looking for T. Excuse me. So I'm going to choose delta Y is equal to VIT plus 1/2 GT squared. The initial velocity is 0. So this portion of the equation is gone, which leaves delta Y is equal to 1/2 GT squared. I'm going to rearrange this for T by multiplying both sides by 2 delta Y, and then I'm going to divide by G, and then I'm going to square root everything, and that is T. And then I plug in my numbers. It becomes the square root of 2 times negative 100. Again, I'm putting in the direction times, or divided by negative 9.8, and that gives me the time. I will let you all plug in the numbers and get the right answer, but basically you know by now, if the equation is right, and you're substituting in the right answers, then other than having a calculator error, your answer will be right. So this is straightforward. This is the first video dropping down. The second video, the object will go up and then come down. And we'll talk about the physics in that motion in the second video. If you have any questions, again, just write them down and bring them to class, and we'll answer them.